Hello, welcome to Ekidel. We are with future civil and structural engineer. Okay, today we will be continuing our 16-story building, and this will be the part 3 of this 16-story building. So right now you can see that on our part 1 we did how to perform the structural framing, where I have to explain all the plan for you, and then on the part 2 we did the column positioning, where we have to frame the structure just like this and position all our columns and all our beams. And same time on the part 2 we have to now begin the modeling, where we have to export this plan and then come to the Protastructure here, and that was on this plan view here, where I showed you guys how to insert your slab, beams and column, and also how to import your plan, your GA plan down to the Protastructure here, and we did the modeling. And so on this part 3 now I'll be showing you how we will still continuing on our modeling stage, because you can see that this is a 16-story building and then we have just done only just the ground floor, as you can see that, which is directly on this place here. As you can see from the 3D view, we have only this area here is the ground floor, and then the first floor slab here, which as you can see on this plan here, you can see that we have several stories to insert, although most of the stories are not typical, so you will be seeing much difference and all that. So right now on this part 2 now, on this part 3, sorry, I'll be showing you how to, as you can see that on this place, on this ground floor, we only have the parking space for the cars, while on the first floor now we have a restaurant and all that. So, and also it also has a wall load, I can see that. So I'll be showing you how to add wall load, and also there is also a cantilever. I can see that this is a cantilever here, and also if you can check the plan view around this place, you will see that there's a cantilever from the left and from the only on the left hand side here, as you can see that, and also on this side too. So I'll be showing you how to insert a cantilever slab, and also how to insert story on this part 3. And then we will also continue to show you how to add wall load to your structure, because most of these beams that you're seeing here will have wall load, because looking at it, these beams here will carry wall loads. And then because if you can look at this place here, you will see that most of these beams here, you can see that there is a wall. This thing here is a wall symbol, so there's a wall which is a block wall that is sitting directly on this beam here. So we are going to add those wall loads now on the beams. Okay, so right now let's go and continue from what we are to do today, which is to insert wall load, insert cantilever slab, and then also insert our story. Okay, so but before we start, I will say that if you have not click on the subscribe button, and if you are new to Ekidel, I'll say welcome. And for you not to miss amazing videos, I'll say that you click on the subscribe button so that you don't miss our amazing videos. And also for those of you that are following this 16-story building design, like I said before, this will be a complete video from start down to the pipe foundation level. So for you to be able to understand how to design a high-rise building, I will advise you get this CAD file, so that you can be able to flow with me on what I'm doing, because it is good for you to use the same plan which I'm doing to for you to follow up this training. Okay, so just check on the link down below and get this CAD file. It is not free, so that, but all the videos will be free, like as we promised. I'll be showing this design will be a complete design. Okay, so right now let's now continue for what we are today. So from this place now, the first thing to do once you come here is now begin to now create the cantilever slab. Now if you now go and look at the CAD file here from this story here, you can see that there is a cantilever slab along this place, and from our view here, you can see that the cantilever slab, this is the ground floor, this is the ground floor here, around this place here is the ground floor, and the cantilever slab is found directly on the first slab, which is, you can see that there's a slab here, which is we are meant to produce or to create our cantilever slab directly from this first slab here. Because this space you're seeing now, this space here, this space below this slab, is this space that is around this place here, is this place here. Okay, so right now on this, now we are going to introduce this cantilever slab. So first thing to do is to go and check the length of the cantilever slab. So let's now go and measure it from the plan view, which is on this place here. So right now, go here and click on dimension and confirm the length of this cantilever slab. I'll do that following the what? The edge of the wall to the edge of the cantilever slab. That gives me 800. I can see 800. I also confirm the same place here. If it is the same thing from here to here, that gives me again 800. Okay. And from here to here again, that gives me what? Let me see. 802. Okay, that's fine. So the cantilever slab on this side and on this side and on this side has a typical length of 800. Okay, and then let's now confirm from the grid line to the edge of cantilever. That gives us what? That gives us 1100. Okay, that's fine. And also the same thing. Let's also confirm from here, from this point to this point here. What do we have? 1100. Okay, that's fine. And then from here again to here, what do we have? 1100. Okay, that's fine. So right now, since we have known the length of the cantilever from the beam end to the edge of the cantilever is 800, and from this grid line to the edge of cantilever is 1100. Let's now offset those two dimensions now. So right now, we now go back to our plan view here, and then we have a cantilever on this face here and on this face here. So with that, now I'll have to offset this grid line by what? By 1100. Okay, so right now come here, right click here, and then offset what? Offset. Come here and click on offset, and wait for it to show the dialog box. Okay, come here right now and then say what? To now offset, to type your value, you have to press your function F2 key. Function F2 key. So press F2 key at your keyboard, and then once you do that right now, next time you do is to do what? Type. I can see that if you're going backward like this, you have to put what? Minus sign. If you're going like this, you have to put what? Positive. So right now, since we want to offset backward, I'll put minus what? 1100, and I'll press what? Enter. Okay, and then you will see that this is now the edge of our cantilever, which we have just created just now at this place here. Okay, here, this one now. Okay, so right now we will now also go and then continue again and then offset for the other one too. So offset here again, from here offset this, offset the same thing, function F2 key, 1100, and then press what? Enter. Okay, which is at axis what? Axis A 16. We can choose to turn this grid line into a hidden grid line. Okay, so I'll turn on my cantilever grid line, which is the edge of the cantilever, into a hidden grid line. Okay, the reason for that is that we will not complete it like just as this one line is trying to complete with the name. So I know that all my hidden lines are the cantilever edges. Okay, so right now come here right now and then say what? Hidden, and I'll come here and then remove these bulbs here. I'll take it off and take it off again, and I'll come here and then click what? Okay, updates, and then you can see that it is now a grid line, but there is no bulb that is showing, and also on this side too there is no bulb showing. So I'll say that this will show us that anyone that has that any line that don't have bulbs is for our cantilever edge. So with that, now I'll also come here right now and then and change this also properties, make it hidden grid line axis, and then come here, remove these bulbs. Okay, and then say what? Update here. That's fine. Okay, so right now you can see that we now have this now. This now becomes our cantilever edges. Okay, so right now that we have now offset on this side and also on this side, let's now insert the cantilever slab. For you to insert cantilever slab, the first thing to do is to do what? Go to your modeling here and then click on what? Slab here. Okay, now wait for it to show the slab dialog box. Okay, so wait for it to show. Okay, it's coming up. Okay, so right now from the slab dialog box here, as you can see just now, the first thing to do right now is to put in your slab thickness. As you can see that we are using slab thickness of what? 150. So I'll come here just now and then put what? 150. Okay, and then once I've done that just now, I will now go over now and then come here and click on what? Loads here. Okay, but before I click on loads, since it's a cantilever slab, you have to change the type from type 1 to type 12. Type 12 is for cantilever. So I come here right now and then choose type 12. Okay, and then come here, you will now see another option. Now, when it was on type 1, there was no option for cantilever. I can see we only have general and then what loads. Okay, but right now once you go and choose type 12, it now show you options here for cantilever. Okay, so on this now I will now go first for and then click on what loads here and loads my slabs. Okay, now for me to load my slab now, you have to come here right now, the dead load 1.5 as before, and then the imposed load, this is a hotel building, so right click here and then choose 2.0, which is for hotel. Let me go and check again. Sorry, right click here and then choose for hotel, which is here 2. Bedrooms in hotels and motels, so 2.0, click there and then come here right now, cantilever, and then you can see that there are several options here, but you just have to pick just this and this. Okay, this L can simply means length of cantilever. That's what it means. So right now our cantilever length from our CAD file here is giving us what, 800. Okay, 800 from the beam to the edge of cantilever is 800. So I'll come here just now and then putting this value here as 800, and then on this place now, which means parapet load. Parapet load simply means cantilever load. Every cantilever must carry load at the edges. Either it will carry a steel handrail or it will carry block wall. So you must put in your cantilever load. Okay, so right now it is also it is good to like design for worst condition. If you can look at this CAD file now and go and check the load that is on this cantilever edge, and we can see that from our 3D view here, from our view here, you can see that what is on this place here, there is no block wall here. If you look at very well, no block wall is here. So this cantilever right now looks as if it's like a balcony. So since it's a balcony, they might have a glass ray or an iron ray to be able to prevent people from falling out. Okay, so with that now we are going to add the load of that glass ray or iron ray. Okay, so right now let's now go and add the load because there's no block wall on the cantilever edges. Okay, so I'm just minimize now and then come here to now add our block sorry, not block, glass load or iron ray. Okay, so basically there is a formula for it to calculate for your cantilever load, which is simply this way, which is simply, yeah, I'm coming by you doing it this. Sorry, let me just begin. Which is simply, if we are going to use a block wall for the cantilever load, and even block wall are what is sitting on the edge of the cantilever, would have done like this. Would have done 3.47, which is the block wall unit weight plus what, plastering left and right of the wall, and then multiply by what, the height of the story. Let's assume 3 meters. Okay, now the load now would have been what, 10 points, then multiply by the block wall thickness, which is 0.225 if you're using 225 block wall. That sorry again, 3.47, which is the block wall unit weight, multiplied by what, by 3, which is the height of the story, multiply again by 0.225 in millimeter. That would have given us what, 2.3. Can you see that? But basically this is the formula for that, 3.47, which is the block wall unit weight, multiplied by what, 3. That gives me 10.41. Okay, so 10.41 now becomes the cantilever load. That is if you're using block wall. So since we're not using block wall now as the cantilever load from our CAD file here, it is saying that what is on this place here is what, is either steel rail or a glass rail. So with that now, the load you have to reduce. So we are going to use a 5.2 load as the load at the edge of the cantilever, which is basically the load either they are using steel rail or iron rail. Just look and be able to take care of that. Okay, so right now once you've factored all your depth of slab, choose type 12 as cantilever length and put in your live load and dead load, everything, and then come here and factor in your length of cantilever and then this parapet load. You have to now come here and then click and to now insert your cantilever. To insert cantilever, you have to insert column to column and then click outside. So right now come here, click here, and then click here, and then click what, outside here, okay, and then again I'll come again once Okay, that's fine. Now to know that you have a cantilever load, you must see this star, this X symbol here, and an arrow symbol at the middle, and also an X. Once you see these values here, that means that there's a load. You can see that G now is showing what? 5.2. This G simply means the load on the cantilever is showing what? 5.2. Okay, so right now let's now continue to go and insert all our cantilever slab by clicking column to column, and then click from here to here and insert. Okay, and again we have cantilever around this point here, and then click from here to here and insert. Okay, and then again from here to here and insert. Okay, and then from here to here and click outside, and again from here to here and click outside. Okay, so right now you can see that we now have cantilever from this point, and also at this point here, and also at this point here. Let's now confirm from our CAD file if that's what we have. From our CAD file now, from this place, which is the plan view here, because we have cantilever from this point here all the way down, moving all the way down to this point here, all the way down to here, hitting this beam, and then also continue again from here all the way down to here. Okay, so that's what we have gotten so far just now. I can see right now from here all the way down to here, all the way down to here, and to here and to here. Now right now you might be asking, why is this cantilever slab not hitting directly at the column here? Basically, cantilever slab starts from the grid line, so basically this one can be done during the construction at site. They just extend their length by this, and then get this shape variable. Okay, that's fine. So right now we now go and check at the 3D view. Okay, so looking at this right now, you can now see that this is now, let me just do it. Okay, you can now see clearly right now our cantilever slab with the loads. So you can see that this is now cantilever slab here having the loads. Okay, I said again, don't mind this thing that is showing here. This will be done at site during the construction. They just extend their slab and then fit into this place here. Okay, there are some things you might not get during the modeling. Okay, but this will really not affect the design. Okay, so right now again we now continue again and then do all this. But if you want to get this directly here, if you want the slab to extend to this place here, then let me just show you what you do to get our slab directly on this place here. Right now I'll have to come here, click on this this my line of extension here, right click here. Sorry, let's check again if this slab here, if this cantilever slab is 800. I doubt that. I'll have to measure right now. Measure first, measure from here to here. Let me see that. Okay, yes, D means, yeah, that's fine. 800. Okay, that's okay. So right now, to now get this slab at this face here, okay, at this face here, I'll have to come here, click here, right click here, and say what? Offset, and move it right now all the way down to the edge of this column here, and click at the edge of the column here. So right now I now have a grid line now on this place. So with this, I can choose to click on this slab now, take the slab properties, okay, and then come here and click here and click here at the edge here, and then come here. Sorry, let me just finish up. Sorry, that's it. There we go. Okay, so right now I'll just click here again. Right now I click here and then say what here, and then come here, cantilever. Now you can see that we have what 800 here before. So right now to now insert this cantilever at this edge, we'll have to change the length of the cantilever here by adding the half of the width of the beam carrying the cantilever. So this beam width now is what 300, which is the half now will be what 150. If you add that to this value of 800 here, we have what 950. So we're going to put right now 950 right now, and then come here, click here, and then click here, and then click up here. Okay, that's fine. So we now have cantilever now hitting at this point here. That's why you have to work with what ghost grid line or hidden grid line. It helps a lot when you're doing your modeling. Okay, and then come here again. We have to have one to be at this place here. So I'll just escape now. Click at this ghost one again, this hidden grid line here. Right click and say what offset, and move it to this place here. Offset to this place and keep this here. Okay, and again click here, right click here, and then say what properties again. Okay, properties again, properties, and then come here right now, loads here, type in here the value 950, and come here, click here, and click here, and then click what outside here. Okay, so without you putting that hidden grid line at the edge of that column, you won't be able to have this cantilever slab now. Okay, so now you can now see what we just got so far. So right now you can see that we now have our slab now directly at the edge of this column, which is what you wanted to see. Okay, so right now we now have it directly at this place here. So we have to use the hidden grid line to be able to achieve this. Okay, and then also on this side too, we also have this also on this side too. Okay, so right now you have now known how to create a cantilever slab. Okay, so basically this now cantilever slab now serves as what? Now serves as the balcony of that. So if now look at this view here, as you can see this view right now, you can now see that we have the cantilever slab here, just as the same thing we have on our view here. Okay, we have cantilever slab only for this place here. We only have it on this story here, which is directly at this end here, and we don't have it at this end here. You can see that it's not at this end here, but from the story 3, from story 2, you can see that this story 2 here, we have it on both sides, which is here and also here. Okay, so right now you can see that from our view we have got it perfectly. Let me just go for other views. Okay, yeah, so from this view now, which we are seeing, from this view which we are seeing, you can now see that what we have got so far is just the cantilever here, which is directly the same thing that is here. Okay, now you can see that the load on the cantilever is basically a glass ray. Can you see that this is a glass ray, okay, and not a block wall? So this background right now is serving as a glass ray, which is the load on the cantilever, which we have just captured here. As you can see right now, we have just captured it here. As you can see that perfectly. Great, that's fine. So right now let's now move on to the next thing now, which is now to insert what? The wall load. Okay, now before we are going to insert wall load, the first thing to do is to insert the story. Okay, we are going to first of all insert the story, which is the next story. As you can see that we are still at this level here, we are still on this level here. Okay, so we are going to insert for this other slab now, which is for this story, which is now this story here, which is now for this story 2 here. Okay, so let's now confirm what is the height of the next story before we can now insert. Okay, so from our section here, we have that the height of this story 1, which is the ground floor, is what? Is 4.9, which is 4,900. So to get it very, very well, you have to subtract 4,900 minus this to get the value. Okay, so also this other one here, so this is the story 1, which is the ground floor, which is basically what we have here. So the level of this right now is what? 4,900. But to get it perfectly, we will have to first of all minus 49 minus 14. So 4,900 minus 1,400. That gives us that will give us the headroom. Okay, so we have the headroom now to be what? 3,500. Okay, so 3,500 right now becomes the height of this, from this beam end bottom to this ground floor slab here, which is the DPC. Okay, then also from the next level now, which is the height, we have 8,400 minus this. That gives us that will give us 8,400 minus 4,900. That will give us 3,500. Okay, that is basically right now it is 3,500 typical. Okay, so let's now add the story for that. So to add story right now, you have to come to this place here, being set out, and then click on what? Story here. By clicking on story right now, you will see what? You will see this right now. Click on this place now, and then you see insert story. Okay, I'm now coming right now, and then do what? Insert story here. Now if I now insert story, I will now be shown this yellow box now. I'll have to put in my height of story here as what? 3,500, as we have shown you just now, and then come here, and then how many story to insert? I say I want to insert just one story additional, so I'll put here story 2, and I'll come here and then say what? Okay. Okay, and I'll come here and then say what? Yes. Okay, now by doing this now, it will just insert just, you can see that we now have story 1 and story 2 here. Okay, now story 2 right now just created just only the grid lines, hoping that there is a difference between this story and this story. But since we have now seen our CAD files that all the columns are the same, as you can see from the CAD file here, all the column position from the first floor and the story 2, which is the second story, they all have the same column position, and we are using the same typical beams. So right now I'll just go back to this place right now and then copy the beams and column to the next floor, which I'll go back again right now, and then come here and then come to this place here that says generate story here, and I'll come here and then pick the option that now says what? That says copy. This is now the source story and target story. Our source story is from story 1, so copy everything from story 1 onto story 2, both what? The slab and the beam and everything, and then I would say what? Yes, okay. And automatically right now it will just copy all what we have here to the next story here, as I see it just now. So I'm not coming right now and then say what? Close. So right now we now have what? We now have our ground floor, and then story 1 slab, and then story 2 slab here. Okay, so right now let's now go and do what? Now go and add wall load at the perimeter of this of this beam. As you can see that from our CAD file here, there is wall load that is on the perimeter here, which is this one here. This hash here means a wall load, and this one also here means a wall load. Okay, so right now let's now go back to our CAD file, but before we add our wall load, let's now go and confirm the height of these two stories now, to check if it's still 35. So confirm here and then come here and say what? Edit story. Okay, now to now edit your height based on what is on the CAD file, you have to go there and then say what? Edit story. Okay, and it will show you the dialog box here. Now you can see that the story 1, which is on this side, which is this one here, this level here, is what? 35. As you can see from our section here, is 3500. Okay, and also from there too is 35. This one of this will give 35. And then let's now from this place here to the DPC slab is what? 1400. So we will have to go and apply that. So to apply this level here, which is the first level, which is called the DPC, is what? 1400. Now come to the software here. The software calls it first story bottom level. So on this place now we have to add that value of 1400. Okay, so this is how to add it. So this now becomes the first story, the first height, which is this one here, which is this first height here. This story 0 is a normal ground level of the site of the area, or let me say of the land. Okay, so we have the first story bottom level, which is the first ground floor slab, where you have your floor tiles. Okay, as this here, 1400 height. And then after that, right now we now have from this minus this will give us 35, and again 35 also. So that's why we now have 35, as you can see, 35 here. Okay, so here, no, here should be 35, not 3 meter, 35 also, 3500. Okay, that's fine. And then we have now inserted these two heights. You can see that once you pass the first story here, which is 1400, we have what? 4900, which you can see directly here to 4900, and then we have what? 8400. As you can see it here also, 8400. Okay, so we are in line with the height as it is on the CAD file. That's why I say to follow up with this very well, and for you to understand it, you must need this CAD file. You can get it directly down below. We are given this video free of charge, but you have to spend your cash for the CAD file to be able to understand. It is good to spend money for your knowledge. So if you want to gain the full knowledge of this design, I would advise you get the CAD file. Okay, now again right now, go back here again right now, and then come here and then click on what? Okay, that's fine. So right now we have just done all that. Now you can see that there is now an increase in height and all that. Okay, so since we have now applied what our height, let's now go and add our what? Story. Okay, sorry, our wall load on the perimeters. Okay, so now to now add wall load on this beam, on these beams here, go back to our plan view here. Now from our plan view right now, to add wall load on your beam, just click on one of the beams you want to add wall load. Right click here and then come here and then click on what? Edit load. Now most of you that are using the wrong version of this software 2022, you will not be able to add wall load, okay, because you are using the wrong version. So if you maybe have that kind of issue, just inbox me down below using my WhatsApp number or my video description, and I will say you what to do and all that, okay, or how to get the right version, okay. So right now, let's now hold on for you to now show the edit wall, edit load dialog box, okay. Okay, so on this now, this is now the interface of what where you have to add your load on your beams or on your slabs, okay. So right now we want to add the wall load on our beams, okay. So looking at this again, let me just minimize, let me just do this like this, okay, that's fine. So looking at this right now, we have to now add wall load. So to add wall load now on your beam, just come here, you have several loads here. Click on the load you want to add, which is the wall load, and click here, wall load. So it now shows the wall load properties here, as you can see just now. So with this now, you have to now apply your parameters for your wall load, okay. But before we do that just now, I'll have to come here first and click at this beam here. It now show the load for the wall load. Then come here and put in your wall unit weight. In my country here, we use a wall unit weight of what, 225. So most of the times in countries like Kenya, Uganda, and then Tanzania, you guys use 250 or 200 as your block wall thickness. In countries like Albania, they use 200 or 250, but here in Nigeria we use 225 as our block thickness, okay. So I will have to add, so now the block wall, like the block wall load of 225 size of block, which is the what is what 3.47 plus the plastering. Now how do you get this load? Basically without the plastering, just the block alone is 2.80, okay. Now since it's 2.80, plastering load is 0.3. Plastering load is 0.3. Now 2.80 is basically the load, the weight of one block. The weight of a block is 2.80. Now knowing that block we are going to have plastering, both internal and what external, now the weight of one plastering is 0.3. The weight of one plastering what unit weight is 0.3. Now if you add 0.3, which is first of all plus 0.3, which is now the internal side, plus 0.3 again, which is what now the external plastering, that gives us what 3.4, okay. So we are sorry, the block unit weight is 2.885, okay, plus 0.3 plus 0.3, that gives me what 3.45, okay. Now we have to now add what, but based on other things, I just make it up to 3.47, okay. So I can use 3.45 or 3.47, but I would advise you use 3.47. So that's how to calculate your weight, wall unit weight. If you add the block wall height, if you add the weight of the block plus the plastering, that will give you your load here. Then also on this place now, you have to now add the height at which the block wall will contain. Now, knowing that our Storey height is what? Is 3 meters. It's 3.5 meters, okay? Now, 3.5 meters now, knowing that there is a beam, a drop-down beam, like there is a beam after the slab, and this block wall will hit directly at the bottom of the beam. So I'll have to subtract the 3.5 minus the beam depth, okay? Now, 3.5 minus our beam depth is 750. So right now I'll have to minus 0.75, okay? Now, since you are working in what millimeter, I will have to do now 3500, which is the Storey height, minus what 750. That gives me what 2.75. So 2.75 is the clear distance that our block wall will like contain, okay? So right now I have to put in the value right now here 2750, okay? Now on this place now, thickness is saying that you are going to insert what the thickness of your block. So I'll say 225 here in my own country block wall thickness. Now once I have implemented all these values right now, I have to come here right now and then say what updates. If I have now come here and then come here say what updates here, it will not change the loads here. You can see that right now. So by doing it right now, we have just added the wall load on the slab. I'll come here right now and then say what okay here. Okay. Now by clicking OK right now, you can see that it is now okay. Okay. So if I now go and check my 3D view here, you see that this now has a wall load here. This is now the color of our wall load here. Now once your beam have a wall load, it will show as a hash. I can see right now it's showing as a hash. That beam will be hashed. I can see right now this is now a wall load. Okay, so on this now we will now go ahead now, and since we have this wall along the perimeter of all the beams, I'll have to now come back to my plan view here, copy this wall load now and paste it on all the perimeter of the beam. So I'll come here right now, right click here and then say what copy load. Okay, so I'll now say okay, yes, copy the wall load and everything. I'll now come here right now and then click at the beams which I want to paste on the wall loads. Hold my control key to now do what they call multi-select. I'll be to click on it now on all the beams which I want to paste my wall load on. Click here and click here also, and then click here also. So I'll click on all the perimeter beams, this also, and sorry, not the grid line but the beams alone, here and here and then here. Okay, and I'll come here right now, right click here, and I'll say what paste load. Okay, I'll say yes, paste load. Now you can see that all the load now is now pasted. Once you see your beam being hashed, you can see that this beam that is hashed now is carrying wall load. Now check on our 3D view right now, you see that all the perimeter beams now has wall load. Okay, so let's now confirm from our CAD file if this one here has a wall load or not. Okay, let's now confirm that. Now CAD file, now let's now confirm our CAD file. This is the area. This is on the CAD file. That's a back view. This place we are seeing here is the back view, and for what I'm seeing right now, there's a window here. So since there's a window, you can see that there's a wall load around this place, and also that continues. Let me check again. Yes, it all has windows. Okay, so since there is window, it all has windows, so there should be a block wall around that area. Okay, around the cantilever beam area. So let's now go back to that place now, to this place here, and then apply our wall load also on this face here. Okay, back to our plan view now. Now since our wall load is still copied, I'll just select the beams again, these beams here, right click here and then say what paste load. Okay, and paste it. Okay, that's fine. And then come here right now to our CAD file here, to our plan view here, and confirm that. I'll send this grid line back to the foundation level to see the building very, very clearly. Okay, that's fine. So right now you can now see that it is now showing that all our beams now, perimeter beams, are carrying wall load. All these other internal beams here, they might use partition walls to do that. Okay, because you can see that from our CAD file here, there is no load on the partition walls here, which you can also see. Let me see that. You can see that there is no much load here. This is basically not a block wall. This is a partition wall. Okay, so so we are not going to add load on that. We have already taken care of this partition wall on our dead load of slab. That's why we put 1 point something as our slab dead load. Okay, so that will take care of this partition load on this internal area. Okay, and all that. Okay, so right now we have just taken into control the this wall load which is on the perimeter here, perimeter around this place here. Okay, that's fine. Although there are season loads. Let me see. On the second story right now we have loads. You can see that wall load is on this other side, but on the story 1 here, no wall load here on this internal place here. But on story 2 we have a wall load on this side. This hash here means wall load, and this side and on this beam. Okay, and then no one around this place here except these ones are line load, which can be taking care of our slab dead load. Okay, can take care of this load. Okay, and then these other ones here, all the major wall loads which I'm seeing. Let me see. No. Okay, so these ones here are the major wall loads here, which is these bigger ones here are the major wall loads which are going to take into consideration. While these other ones here, can be taken care of by the slab dead load. Okay, so right now let's now go to our model right now. So you can now see how we have modeled so far from how we added the cantilever load and the cantilevers, and also inserted Storey, and then also inserted this wall load. Okay, so right now you can see what we have just done so far. So we are done with this part 3. Now on our part 4, we will be taking care of other things also. Now I'll say that if you have come to this end, I'll say thank you so much, and but I'll say that you should click on the subscribe button and also turn on your video notifications so that you don't miss all our amazing videos. And also I will say that you should share this video to your friends and colleagues and let them know what is happening here on Ekidel. And if you have any question and comments about this, I'll say you should drop it down below. Now, special information: on this month of September, we announced that we are giving out 50% discount on our Ekidel mentorship class, where we have to teach you structural design. Now, what we are doing here on our free channel, we might not be able to explain everything because of the time and also video duration. But on our special training, which is the Ekidel mentorship training, we will train you till you are good in design, and it is a live screen sharing. So depending on your country, anywhere you are, we will train you, and you will be able to see our screen, and also we will be able to see your screen when we are training you. We can see your screen from our end, and you'll be able to see our screen from our end, live screen sharing, and we will train you on design. Now we are giving out 50% discount for this month of September. And after this month, it will be back to its normal price, which is very expensive. But for you to be able to achieve that, you have to don't miss out this discount we are giving out this month of September. Don't miss it out. Okay, so that's just it. That's what I have to tell you guys. So right now we have done this so far. Now we will have to now move on to the next, which is the part 4, which will be coming out next week or later this weekend. Okay, so thank you so much and God bless you. If you have any questions so far, drop it down below, down on my comment section, and then God bless you. Now we also have a group chat where all our Ekidel engineers, all the subscribers around the world meets and then share knowledge. So you can also check the link down below and then join the group chat for our WhatsApp. Okay, so thank you so much and God bless you. We'll love you, and then goodbye for now, and see you again on the part 4 of this 16 story building. For now, bye for now.